In this lesson, you will learn about the changes in states of matter, heating and cooling curve. The success criteria for this lesson are: 1. Explain the process of melting, freezing, boiling, evaporation, sublimation, and condensation. 2. Explain heating curve and cooling curve. Let us now dive right in to learn about changes in states. A change in state does not produce new substances. It is a physical change only. Changes of state always occur with a change of energy. Energy is either given out to the surroundings or taken in from the surroundings. This diagram shows the summary of the exchange in energy during the process of melting, freezing, boiling, evaporation, sublimation, and condensation. Melting is the process by which a substance changes from a solid to a liquid. When a solid is heated, the particles gain kinetic energy and vibrate faster. Particles overcome attractive forces between them and break away from fixed positions. Particles then slide over one another, and the solid has melted to liquid. Freezing, on the other hand, is the change from a liquid to a solid. The temperature at which a liquid freezes is its freezing point. When a liquid is cooled, particles lose kinetic energy and move more slowly. Some particles then start to settle into fixed positions. When all the particles settle into fixed positions, the liquid has frozen into solid. Let's now look at boiling and evaporation. Boiling is the change from a liquid to a gas at the boiling temperature, and the temperature at which a liquid boils is the boiling point. Evaporation is similar to boiling. Both cause a substance to change from a liquid state to a gaseous state. However, there are differences between them as well. Boiling occurs only at boiling point, while evaporation occurs at any temperature. Boiling occurs throughout the entire liquid, while evaporation occurs only at the surface. Next, we look at sublimation, which is the change of state from solid to gas without melting. An example of a substance that sublimes is dry ice or solid carbon dioxide. The change of state from gas to liquid is known as condensation. When temperature drops, gas particles lose kinetic energy and move closer to each other. The attractive forces between the particles increases and the gas becomes a liquid. For the next part, we're going to talk about the heating curve and the cooling curve. A heating curve shows the changes in temperature as a pure substance is heated from solid to liquid to gas. At A to B, substance is in solid state. The temperature increases, the particles gain energy and vibrate faster. At B, substance starts to melt as particles in the solid gain enough energy to overcome the very strong forces of attraction between them. At B to C, melting takes place and there is a mixture of solid and liquid here. The temperature remains constant even as heating continues, because all the heat taken in is used to overcome the attractive forces between particles at C. All the substance has melted. Thus the substance is now in the liquid state. At C to D, substance is in liquid state. As the temperature increases, the particles gain energy and vibrate faster. At D, substance starts to boil as the particles in the liquid gain enough energy to overcome the strong forces of attraction between them. At D to E, boiling takes place and there is a mixture of liquid and gas. Temperature remains constant as all the energy taken in is used to overcome the attractive forces between particles. At E, all the substance has boiled. Thus the substance is now in the gaseous state. E to F, substance in gaseous state. Particles gain energy and move faster, and temperature increases. Now, we proceed to look at a cooling curve, which shows the changes in temperature as a pure substance is cooled from gas to liquid to solid. At P to Q, substance is in gaseous state, and as temperature decreases, particles lose energy and move about randomly at slower speed. At Q, substance starts to condense as particles in the gases lose energy and move slowly and closer, and the attractive forces between them increases. At Q to R, condensation takes place. Substance exists as a mixture of liquid and gas. Temperature remains constant even as cooling continues. Heat is released as particles form strong attractive forces between each other. At R, all the substance has condensed. Thus the substance is now in the liquid state. At R to S, as temperature decreases, the particles lose even more energy and move even slower and closer. At S, substance starts to freeze as they lose energy and move slowly and closer, and the attractive forces between them increases. At S to T, freezing takes place. Substance exists as a mixture of liquid and solid. Temperature remains constant even as cooling continues. Heat is released as particles form very strong attractive forces between each other. At T, all the substance has frozen. Thus the substance is now in the solid state. At T2, temperature decreases, particles lose energy and vibrate less vigorously. Finally, we want to discuss how the particulate nature of matter helps us appreciate other phenomena such as diffusion. Diffusion is the movement of molecules from a region of higher concentration to a region of lower concentration down the concentration gradient. We can show diffusion in the laboratory by placing a gas jar of air over a gas jar containing bromine vapor. A few minutes after the cover is removed, the gas in both gas jars looks the same. Diffusion also takes place in liquids, but at a slower speed. With this, we have completed this lesson on changes in states of matter, heating curve and cooling curve. Hope you enjoyed the learning.